welcome to this new tutorial. We will be recreating this old tutorial, but with the new geometry node fields version. A lot of people requested this, so here it is. We will remove the cube, and in this case we will start with a Bezier curve, geonodes, start anew. We will start with the basic shape for the posts. I will add a cylinder here. I will add a value for the height. We will connect this here. We will use instance on points, and we will use the points of the Bezier curve, and the instances will be our cylinders. I will change the radius to 0.1 maybe. This is on the center of our cylinder, so I want to compensate our height, so it's sitting on the land there. I will use a transform, combine, math node, and multiply. So I will get half of my height and use it on the positive C. So it will move half of the size up, and we get this. So now if we change, it's always sitting on the land. Now I want to create like the T-shaped thing there. For that I will use a cube. I will join them, and I will use also a transform to move it up. I will change the size a bit. 1.5 maybe, 0.2, 0.09. And now we have to take the height math, and we can, for example, multiply our height by a number from 0 to 1. So for example, at 0.8 of the same height, we need to combine also, and we use this. And see. And this part is ready. Ctrl J, box. Now if you move this, it moves, but if we rotate this, nothing happens. Okay, we will grab on X maybe and put it around there. First I want to take a sample of this curve, and I will get some information of the curve I plug here. We have the position, tangent, and normal, depending on our factor or length, because these are fields, so it has different values on different positions. It's not a single value or a uniform value. And I want to align the rotation of this object, of this point, basically, to the tangent of my curve. To do this, I will use an align Euler to vector. The vector that we are going to align to is the tangent of this curve, but we need to use also a curve parameter, because at this point we have the tangent of the point 0 of the curve. For example, for this point I want the 0.1 tangent. So I will use my factor here, and I will use my rotation on these points here, on the rotation of the points there. So now, as you can see, they face the same direction that the curve has there. So if I rotate this and see, you can see, and it works on all axes. If I don't use the factor, they are taking the tangent of the point 0, so they both face the same direction as this, because this is the zero factor of the curve. So they rotate the same way. If I use the 1, they will take the tangent from this point, because we are at factor 1. But if we use the factor of the line, every point gets the tangent of that point. The other thing that this had was a random tilt value. So I'm going to add vector math, and I will add to the rotation we have now, and I will use a random value. It's a vector. I don't want to mess with the rotation on the z-axis, because I want to control that with this. So I will only use random on x and y axis. Minus 0.1, 0.1, add this, and I will remove this. So we have 0 from 0 to 0 on the z-axis. And now you can see we have a seed here. For example, use a vector math if you want here with a scale, and set this to 0 to have no effect. And as you reach 1, it will have full effect. So you can expose this value, and maybe also the seed, tilt amount, maybe tilt seed 0 to 1, and the seed, if we extrude with E, we can create new posts and rotate them. We can take everything here, Ctrl J, and this is our alignment and random rotation or T. Now we have to create our cables. And at this point, it's important to understand that I will create a little demo here. It's important the order in which you add the transformations to the objects. For example, the transforms. Let's say I want to rotate this object and move it. For example, I will rotate on the z-axis and then move it 1 on x. Let's move it a bit more. Okay, here. So the object is rotated and moved. But what happens if we do it the other way around? You see that you don't get the same result because we are first moving our object and then it rotates around the original point, as you can see. Just to clarify that it's important to have in mind that the order in the transformations affects the result. On our case, this is very important because if we do it incorrectly, the lines will not stick to the parts here. That said, we are going to take the same curve and we are going to move it to create these lines. I will take from here. If you have no wrangler, it's Shift, right click and drag to create reroutes. We will use different set positions here. Set position. I take one. After this, I will use a join here, join geometry to see what I'm doing. And I will plug this. I can see the line here. I will move this. I will take the value I'm using to move this part up. In my case, I like to do this Control Shift, left click, and then I create a reroute here. So I can drag this. Now I need, if I plug this on the position, all the points will go to the position we have here. So up, and that's it. All the points are there. This is just the handles making a shape there. So we need to use our original position for this curve. With vector math, we will add this height and we can plug this on the position. Okay, that's the first step. Now I will offset this one. I will put 0.2 here. And now we need to take care of the rotation. I will plug this here. This goes back to 0. And to create our rotation, we are going to use a vector rotate. We change this to Euler. What we are going to rotate, it's our current position. We are going to rotate it around the old position they had. In this case, that position is here because we are sampling the curve before we do changes to it. This is our center, and our rotation is the same rotation we did to the points. So we get the same rotation this has. We apply it to this new line, and the center is this. So they rotate around the same point the posts are rotating. And we use this on our position here. So as you can see now, you can do whatever you want. They won't detach. For example, if you scale this curve, you see, it's the same as a Bezier curve behaves for the part, the top also. Okay, now we will repeat this for the 6 different cables. And as I said before, that the order is important. As you can see, if we disconnect this here, we connect it here, and we plug this again, it's not working correctly because they are rotating around themselves or locally. Okay, so let's put this back here and our rotation, Control Shift duplicate. And now I will change the offsets. This is maybe 4, 6, and to the other side it's -2, -4, -0.4, and -0.6. Close this. We'll cut this, and I will plug the new ones. Now I have to join them. Now we will take care of the tension of these cables. This has 2 points, one here and one here. So I will subdivide the curves to have one on the middle. Subdivide, not resample, one time. So that's one on the middle. Now I'll use a set position. And if I use it now, everything moves. What I want to do is to create a selection that will give me just the point on the middle. And I need also a value that tells me how far away is this point from the posts, so I can calculate how much it needs to go down. To do this, create a bit of room here. To do this, we need the distance from this post to the point. So I will use geometry proximity. This cannot work with instances, so we need to realize the instances. Okay, at this point we have the distance from the faces of these posts to every direction. So I will use position as a source position here. To select just this value, I will use math node greater than, and I will assign a small value here. And this will be my selection for now. As you can see, if we move, now we have this. To create, now if we move this, nothing happens, right? Because this is a fixed number, we have to make this dynamic. So I'm going to use the distance on a map range. I will use a combine XYZ and connect this to my C value. Let's connect this to our offsets here. Okay, we have this because this is a positive value. Let's make this negative. So far it's working from 0 to 1 meter. That's too little, so I will add this like 10, for example. And the thing is, as I get far away, I get more distance, and this goes down, and we need to work the other way around. So I'm going to add 0 here, or maybe a little value, we will see later. And this will be, for example, -4. At 0, it will be -4, and at 10 meters, it will be 0. You will decide how much you want to give it. We can also add some difference in the height. So we will use a random value here between maybe 0.8 and 1, this value, by this random value. And as you can see, as we increase the difference of the random value that they get, we get the difference there, and we can use the seed to change the difference in height of the cables, the variation. After we create our set position here, we will use a curve to mesh. We will use a curve circle with maybe 0.01, and we'll use 6 here maybe. Okay, we have this, and as you can see, we have this low resolution curve. If we increase this, we will break everything, so we won't do that. What we can do is, after we create the new position, the bending, we can create another subdivision here and add maybe 1 or 2. And now it's looking way better. The direction they take here, if you want this to go instantly down, you can decrease the size of this, as you can see. Now you can extrude all you want. You can expose all these values and play with it. Okay, I hope you have liked this tutorial, and see you on the next video.